I sat down at my computer at 1 minute to 9 and realised that it was plugged in at the computer bit, but not at the plug. Classic theatre of science. So I'm just going to point you here for 1 minute while I do a minimal amount of faffing. Can you tell me, is the sun a solid or a liquid or a gas or something else while I turn my dishwasher off and blow my nose? And then we'll start the lesson. Okay, job one. I'm just finding the red paint. Because it's YouTube, innit? So this needs to be the best version of the lesson that it can be. Yeah, that's better. Just adding some finishing touches to my Northern Lights costume. Absolutely nailed it, as usual. Okay. All right. Oh, I've even got coffee. Sorry, everybody. Right, we'll get started. Pew! Hello, Science Light. Oh, I look horribly ill, don't I? It's just not worked at all. This is not... I don't really feel like this face paint is screaming Northern Lights, but I've made it brown. It's a good job this isn't recorded forever on the internet, isn't it? Hello, I am Lara, and this is our 5th lesson on the polar regions about the Northern Lights. But you do not need to have seen the previous lessons to come to this lesson, because it's just a standalone lesson about these beautiful, beautiful sheets of purple and green and red and pink light that people see hanging from the sky just around the poles, just around the North and South Pole. Here's a picture. Picture what an astronaut who was actually on a spaceship orbiting Earth, the International Space Station. It's above our heads right now, going round and round. Just took this photo. So this is a lovely one from above. Here's another one. Thanks NASA for these. So what causes these? We're just going to do a whole lesson about the science of it. And then if you come to my Lego Storytime shows, we will actually do straight after this a Lego Storytime show about the Northern Lights and look a bit more at the kind of history and myths around them. Right, so to understand how the Northern Lights work, the first thing that you have to know about is atoms and something that's happening in the sun. So I'm going to show you this PowerPoint. I hope you enjoy it. It took me ages. Here is an atom. We're just going to say that an atom is a positively charged particle called a proton with a negatively charged particle called an electron whizzing around the outside of it, okay? So that's all you need to know about an atom for today. So I asked you if the sun was a solid or a liquid or a gas, right? So these atoms, proton with electron going around it, they make up everything. Everything you can see around you is made of an atom. Atoms, if they're in a solid, like, I don't know, a table or your body, they don't have that much energy. They are moving, but they're all bonded together, so they're just sort of vibrating on the spot. In a liquid, like water, they're still touching each other, but they can move around. It's kind of like a ball pool, so they've got a little bit more energy in a liquid. In a gas, like the air that you're breathing in, the atoms have got loads of energy. They've completely broken free. They're just flying around, hardly touching each other at all. So you might have said that the sun is a gas. I wouldn't have been exactly wrong, except the atoms in the sun, like they've gone even further. They're so hot, they've got so much energy. They're not even really a gas, they're like one step beyond. The electron and the proton have broken free from each other, and it's called a plasma. So I've said it's The sun is kind of like a loose soup of protons and electrons. There's some other particles as well. We don't need to know about those today. So these protons and electrons that are just flying free as a plasma in the sun, here they are. The sun gives them off all the time. So this plasma, these protons and electrons, they are constantly streaming off the sun. It's happening right now, every day, every minute of every day. And where are they going? They're heading for Earth. You ready? I really had a lot of fun with this PowerPoint. Pew! Here they come. Oh no! What are we going to do? By the way, when they're streaming around, we call them the solar wind. So all these protons and electrons flying around space is the solar wind. That is important. There may even be a quiz about it later. So this is the solar wind, this plasma of protons and electrons flying off the sun, the solar wind. FYI, I thought this was a cool fact. Comets, like big balls of kind of ice and rock floating around in space, they've got two tails, because when they get close to the sun, the solar wind actually blows some of the stuff off in the direction of the solar wind. That's good, isn't it? So there you go, it's the solar wind. Right, let's do activity 1, shall we? Have you got, I can't believe how bad this is. The Northern Lights are so beautiful and mysterious and elegant, and I don't know what is happening here. Have you got a pin or a needle and a magnet? I'm so embarrassed. It's the most embarrassing costume I've ever worn, like really saying something. Can you, first of all, just hold the pin and hold a magnet and put them close to each other but not touching each other? Can you feel them pulling on each other? With apologies, if you come to my free live IGCSE physics lessons, we've just done this because we've just done magnetism. So I'm sorry if this is a repeat. Sometimes it's just going to happen. Can you feel them pulling? Even when they're not touching each other? What is going on there? I mean, obviously we know this, right? If you put two magnets together, you will feel them pull towards each other or push away from each other, but they're not even touching. So how do they know that each other is there? Like, is the air between them sending some sort of signal? What's going on? Well, what is happening is magnets have what we call magnetic fields around them. Here is a picture. It's obviously a made-up picture because magnetic fields are invisible, but the needle can feel the magnet because the magnet has this magnetic field, like a force field around it. So this is how physicists draw it, even though obviously we can't see it. These green lines going from the North Pole to the South Pole, that's the magnet's magnetic fields, and these lines are magnetic field lines, okay? Right, so that was activity 1. I hope you enjoyed it. Now what I need you to do is to hold the pin, carefully hold the pin, because it's a pin. Hold it carefully. Hold the magnet in just one, like hold it the same place every time, and hold the pin in the same place every time. And you just need to stroke the pin with the magnet, but just stroke it one way, and then pull the magnet away and take it right back to the beginning and stroke it again, all right? Like this. So what we're doing is, your pin is made of a magnetic material. It's got like iron in it. And iron atoms are basically like teeny tiny little magnets. But usually they're all pointing in different directions. So overall, the iron, or the pin in this case, is not a magnet, because the magnets are, all the little atom magnets are all like out of alignment. But when you stroke your pin with a magnet, you're making all the magnets in the pin face in the same direction. So we're basically turning our pins into magnets when we do this. I'm lucky I've got quite a strong magnet, so I don't have to do it that many times. But you keep stroking, and I'll just show you something on the screen about magnets that will help us understand how the Northern Lights work. I want this to be really good. I think it's okay. When I put it down, I'm not going to be able to pick it up and stroke it again, because I'll forget which end of the magnet I was using, and I don't want to just reverse all my good work. All right, I'm just going to say that's done. Here we go then. Have a look at this. Oh yeah, just a little hint for where this is going. Charged particles can also feel magnetic fields. Charged particles like protons and electrons, they can feel the magnetic field around a magnet. Right, here's some magnets. Magnets have a North Pole and a South Pole. A lot of people already know this. Like poles repel. That's a posh way of saying poles that are the same push away from each other, like this. You ready? So if a North Pole and a North Pole of a different magnet are put together, they will push away from each other. Whereas opposite poles, or if you're doing IGCSE physics, call them like poles, like North and South, they're attracted to each other. So what you're doing is you're making your needle have a North Pole and South Pole. And then what we're going to do is we're going to put it on top of a bit of leaf. It's just the best way to do it. Where's my bit of leaf? Oh, here it is. Just put the needle on top of a bit of leaf and then rest it in a bowl of water. And then we should see something cool happen. So let's have a look. Take you off here. There we go. I hope this works. Oop. Gently. Yeah. Whoa, look at that. So straight away you can see it's really spinning around really quickly. And it's settling down. And now it's stopped. Okay, so I'm just going to turn it around again to see if that happens, test if that happens again. Yeah, look at that. That's good, isn't it? The needle just wants to face in one direction. I'm going to try it once more. Just spin it right around. Oh no, it's falling off the leaf. Oh no, oh no. Needle overboard. Put it there like that. It really does just want to face one way. Why is that? Well, it's because, and I know a lot of, like, we know this, sort of, most people know this, but it's just something that you get used to. Earth is a magnet. Earth is a massive magnet. It's got iron in its core, all churning around. So Earth has these magnetic field lines around it, just like a massive magnet. Animals like pigeons can sense those magnetic field lines and use them to move around. It's amazing. So the needle is lining up because it is now a magnet. It's lining up with Earth's magnetic field. I mean, it's just magic, isn't it? So here is something weird. The North Pole of your needle is lining up to face the North Pole of the planet. Why is that weird? How well have you been listening? Given what I've just told you, oops, zoomy zoom. A compass needle is a tiny magnet. So your pin in this case, because you've just made a kind of floating compass. It's a tiny magnet, is that needle. What's weird about the North Pole of a compass needle pointing to the North Pole? So I've got, if you've got my worksheet from my website or my Facebook group, you've got this in front of you. You've got the North Pole at the top of the planet, what we think of as the top, where the polar bears are. The South Pole, where the penguins are. And this big magnet, which I haven't labelled, in the middle. What's weird about the North Pole of a magnet pointing towards the North Pole? If you like, you can even try and label your magnet or quickly sketch to make sense. Because like poles repel, don't they? I've just told you that a north and a north will push away from each other. So surely the north end of our needle wouldn't be attracted to the North Pole because they're supposed to be like pushing away from each other. What it is this is where things get incredibly confusing. This is the geographic North Pole, what we think of as the North Pole. Like in geography terms, it is the North Pole. And the South Pole, again, it's the geographic South Pole. But if Earth is a magnet, it's actually that the South Pole of the magnet is at the North Pole. And the North Pole of the magnet is at the South Pole. It gets even more confusing than that, but we're just going to leave it like that for now. So if Earth is a magnet, the South Pole of the magnet is at the North Pole. Is that okay? I know, it's very weird. I want you to fill in this. Oh yeah. I haven't told anyone else this, actually. The magnetic poles actually switch around every so often. And when they do, it's completely unpredictable. It could be every 10,000 years, could be 50 million years. It happens quite quickly when it does happen. The last time it happened was about 780,000 years ago. I know. Right. Have a go at this for me, please. This is quite, some of you will find this easy and some of you, like me, will find it deeply confusing. Earth is a giant magnet. The geographic something pole is the magnetic something pole, and the something South Pole is the something North Pole. Can you please fill in the somethings for me? while you finish that, we'll grab my little globe. Where did I put it? There we go. Have you done that? So I had the geographic North Pole is the magnetic South Pole, and the geographic South Pole at the bottom is the magnetic North Pole. It gets even more confusing than that because a lot of people call the magnetic pole, which is at the North Pole, the magnetic North Pole, even though actually it's the south end of a magnet. If you look up on the internet, like, where is the magnetic North Pole, it tells you that it's in Canada. But some people say the magnetic North Pole is where the north end of the magnet is. Deeply confusing. I'm going to be calling the magnetic North Pole, when I say magnetic North Pole in the rest of these lessons and in the quiz later, I mean the magnetic North Pole, like where the North Pole of Earth's magnet is, okay? In the south. It's just words in it. This isn't science, just words that humans have made up. Okay, so the big question is, because why are we talking about magnets anyway? What happens when the solar wind, do you remember the solar wind, hits Earth's magnetic field? Here it comes. Oh no, what's going to happen? Well, it's okay. Fear not, Earthlings, because our planet has something called a magnetosphere. Here is a beautiful artistic representation of what the magnetosphere looks like. So we've got the solar wind coming in here, these yellow lines. Earth is tiny in the middle here, and all around Earth we've got these lines which are Earth's magnetic field. And you remember I told you that charged particles like protons and electrons, they can feel magnetic fields. It's a kind of two-way relationship. So the solar wind kind of, it can't get through Earth's magnetic field, but the solar wind also sort of shapes Earth's magnetic field into this beautiful teardrop shape, which is called the magnetosphere. Here's another picture. Here we go. So, yeah, so you can see here, this is where the solar wind comes in from the left. And then you've got this big, what is that? Sort of looks like, well, it's called a bow shock. It's this shock area where the solar wind is smacked into the magnetosphere and then being deflected all around it. I thought this was the best picture for us to use to actually learn. So you've got Earth, this tiny little Earth, looking tiny compared to the huge magnetic field lines all around it. These are the magnetic field lines in sort of brown. The solar wind is these yellow lines coming in from the left. And this bow shock here is right at the front of the magnetosphere. That's where the solar wind smacks into Earth's magnetic field. And the whole thing is called the magnetosphere. And it stops the solar wind getting to Earth, except it doesn't actually quite. So there is a little place where the solar wind, those electrons and protons from the sun, where they do get to Earth. Can you see where that is on this diagram? Can you see where the solar wind is getting in, where those yellow lines are getting in? Yeah, it's getting channeled towards the poles, isn't it? Oh, finally, we're starting to get there. Yeah, so the solar wind, generally, it gets deflected, but some of it travels down these magnetic field lines to Earth's poles, because that's where the North Pole and South Pole of the magnet are, right? So that's where, like, the magnetic field lines are strongest. So then what happens? Well, so I went a bit fast with this yesterday, I think. If you got, this is the bow shock, the bit at the front of the magnetosphere. This whole thing is the magnetosphere. And we're now talking about these protons and electrons being given off by the sun, and some of them have got to the North and the South Pole. What happens when that happens? Well, it's time for activity 2. Very tenuous activity 2. Have you got a candle? If you don't usually use candles on your own, if you're on your own, probably don't use a candle. But if you've got an adult with you, then light the candle and get some salt. And we're just going to talk about what happens, why, when protons and electrons stream down Earth's magnetic field lines to the North and South Pole, do you see northern lights, or indeed southern lights? Well, we'll do this in a bit more detail in LEGO Storytime Show. But basically, very basically, Earth's atmosphere, like the air, is made of atoms as well, okay? Obviously, oxygen that we breathe in, nitrogen atoms, we're just going to keep drawing those atoms as just one proton and one electron to keep it simple. So what happens is these atoms of oxygen and nitrogen just floating around in the air in our atmosphere above the North and the South Pole, they get whacked by these protons and electrons. And when a proton or electron collides with an atom of, let's say, oxygen, it gets excited. Bless it. I mean, it is exciting. What happens when an atom of oxygen gets excited is that its electron sort of goes up a bit and then relaxes. So the electron gets excited, it jumps up, and then it jumps down again. And as it jumps down, that energy has got to go somewhere, and where it goes is into a particle, actually, of light. Oh, it's green, it's oxygen. So solar wind hits oxygen in Earth's atmosphere. The oxygen atom gets very excited, or molecule. It's an all ages lesson. It's an oxygen molecule, but forgive me. And then when it gets less excited, it gives off a particle of green light. And that is what you're seeing if you are lucky enough to have ever seen the Northern Lights. I mean, it's kind of greeny, reddy light. Nitrogen particles, when they get excited, they give off a sort of reddy, purpley light. So there you go. We got there. Now, I was thinking of things that you might have around your house that give off light. And because actually, yeah, we'll talk about this in more detail in the Lego Story Show, but all atoms give off different kinds of light. It's kind of like a fingerprint. And you've got probably in your house a chemical called sodium chloride, which is salt. And salts tend to burn different colours. Now, the kind of salt that we eat, like table salt that we have in our house, it burns. Guess what colour it burns? It's really amazing. What colour does the salt in your house burn? It burns yellow. I know. Behold, children, as I make this candle flame burn yellow, right? Woohoo! Let's give it a go anyway. This poor candle has kind of had enough, actually. I thought I had another one here. It's looking a little bit on its last legs, but we'll give it a go. So first of all, I've got some table salt, which I've ground down as much as I possibly can. So it's got a big surface area, so it hopefully burns more. I'm going to sprinkle it onto the candle, and you can say whether you think it's burning. Yeah. Oops. I'm just going to go and get a different candle. This one was scented anyway, so incredibly annoying. All right, here we go. To the candle drawer, to the bits and bobs drawer in the kitchen. There we go, that's better. Every time I flip the camera back on my face, I'm like, ah! Oh, yeah, that's what you did. I'm going to have to change this face paint for the Northern Lights Lego Storytime show. There. In fact, it's the last one. Let's do 2 candles. Because I've got another salt to burn. Oh, yeah. Here we go. Come on, guys. You can do it. All right. This is good. We'll put both of them together. So, first of all, just normal table salt. Hopefully that you've got 2. What do you think? Is that burning more yellow? Definitely looks more yellow, doesn't it? Whoa, really, really, really? Oh, that's great. Oh, I feel so sorry for the poor people on Facebook because I hadn't ground it up as much yesterday. And I wasn't using this candle, and that's so much better. All right, so that's cool. And maybe you're seeing that too if you've got this in your house. But what I want to do, and I'm excited because I've ground it down a lot more again, and they're bigger candles. There's a different salt, which is also perfectly safe, it's edible, called potassium chloride, which we don't usually have in our houses. Now, I could have just ordered in some potassium chloride and some ethanol and set up a proper experiment where we could watch it burn a different colour, but I didn't do that because I don't expect you to spend any money on these shows. I'm not going to spend any money on them either, frankly. So what I bought was this stuff, Herbamare. I can't lie, I haven't eaten any of it. It's like a low salt version of salt. But the first ingredient is potassium chloride. It also has some horseradish, rosemary and leek in it. So what I did was, because I'm a, totally reasonable person, I put it in some boiling water so that the potassium chloride salt would dissolve. And then I got a coffee filter and I poured that through the coffee filter so that all the celery and garlic and stuff got caught in the coffee filter. Then I poured the boiling water that just had potassium chloride in it onto a plate and I let the water particles evaporate off for about a week. And now I've ended up with just this only slightly garlicky collection of potassium chloride crystals, which I've ground up into a very fine powder, and I am about to sprinkle onto these candles. And for the first time, like when I did this on Facebook, I told them all what colour I was expecting to see. I told them all what colour potassium chloride burns. But I finally remembered to not do that, because this is much better science. See if you can see a colour that isn't the regular colour of a candle flame when I put this potassium chloride. Again, it's just a salt. It is edible, but you don't tend to have it in your house. The only place I could find it in the shops was this thing. So let's have a go. Oh, I'm nervous because it hasn't really worked on Facebook, but it is a lot finer this time. Let's do that again. Well, if you're not impressed, I have to tell you it's working a lot better than it did on Facebook. I'm going to zoom right in. Let's have another go. I should have said before, don't put your hands too close to a candle flame, please. What colour do you reckon? There's definitely something there, isn't there? Wow, I'm quite pleased with that. It's supposed to go purple. So if you're saying blue or purple, then it's actually worked. Oh my goodness, right, let's just chuck the whole lot on and then I'll do a bingo quiz to finish. That's definitely purple, isn't it? Oh, so cool. Let's try the other candle. All right, now, come on. Well, I think that's not too bad. Thank you for joining me. I'm quite impressed with that. So what's happening is those salt atoms are getting excited and giving off yellow or purple light. Right, are you ready to play bingo? I've got a grid here to finish off of 4x4. And what I want you to do is I'm going to ask you some questions, and I want you to circle the answer as you get the answer, and then if you get 4 in a row or 4 diagonally, then shout bingo to yourself and you will have won. If you haven't got the worksheet, doesn't matter at all. Maybe just draw a grid of 4x4. Don't bother writing in all the words, but if you've got a grid of 4x4, you can just see on the screen which one is the answer and just put a cross in the box, okay? So here we are, here's the grid. So the top line is from left to right: solar wind, south pole, magnetic field. Solar wind, south pole, magnetic field. The second line is field line, plasma, electrified every year. The third line is everyday, electron, bow shock, magnetosphere. And the fourth line is geographic, excited, solar fluffy, and north pole. So it can be up, down, or diagonal. Let's do this. Oh, a quick shout out before we do to Sebastian and Humphrey, who are in hospital at the moment because one of them has broken both their legs in a bunk bed related accident. Dudes, we are thinking of you here at the Science Lines. Right, question number 1. What is the name of the plasma which streams off the sun towards Earth? What is the name of the plasma which streams off the sun towards Earth? Be careful here on Facebook. Everyone was getting false bingos. What is the exact name of the plasma which streams off the sun towards Earth? If you get this one wrong, you're going to get a fake bingo. Or as they were calling on Facebook yesterday, a bing no. Question number 2. And how often does this happen? So the sun gives off a stream of plasma. What is that stream of plasma called? And how often does the sun give it off? Oh, shout out to Sophie as well, who is watching for the first time. I hope they're still here. Okay, third question. I haven't phrased this very well. The magnetic south pole is at the geographic something. What I mean is the south end of Earth's magnet is at the geographic something. The south pole of Earth's magnet. Earth is a giant magnet. Where is the south pole of Earth's magnet? At the something. Okay. Question 4. Name a particle that streams off the sun.
Name a particle that streams off the sun. There's only one answer that it could be here. I like how there's more people joining us. Have you heard? Theory of Science is doing bingo. Question 5. What is the name for the teardrop-shaped magnetic barrier that protects us from the solar wind? That's quite hard, that one. I thought we went through that bit quite fast. What is the name, so this thing in the picture here, for the teardrop-shaped magnetic barrier that protects us from the solar wind? Is it magnetic field, magnetosphere, North Pole, bow shock, South Pole? What is it? Have you got all those? What's the name of the plasma which streams off the sun towards Earth? How often does that happen? The south end of Earth's magnet is at the geographic blah blah blah. And name a particle that streams off the sun. And now the name of the teardrop-shaped magnetic barrier that protects us from the solar wind. All right, question 6. Atoms in our atmosphere that collide with the solar wind are, what are they? Are they electrified? Are they magnetic? Are they excited? Are they field line? Are they solar fluffy? What do you reckon? Oh, hello, Imogen and Ophelia as well. I know you're watching at the moment. Bethany and Bonnie, you guys as well. I did have a quick look at Facebook while I was waiting for YouTube to load up. Right, question 7. The front of the magnetosphere, the bit where the solar wind collides with Earth's magnetic field, is called the front of the magnetosphere, the bit where the solar wind collides with Earth's magnetic field. What is that called? Solar wind, South Pole, magnetic field, field line, plasma, electrified, every year, every day, electron, boson, magnetosphere, geographic, excited, solar fluffy, or North Pole? Whew. Question 8. A compass needle is... What is a compass needle? Is it electrified? Excited? Is it geographic? Okay, so if you're shouting bingo, well done. Yes, you should have got a bingo by now. I just, I couldn't finish on the question where you got a bingo, because otherwise you'd obviously know that it was bingo because the quiz would have finished. So well done if you have bingo already. Let's go through the answers. What is the name of the plasma which streams off the sun towards Earth? It's the solar wind. So if you said plasma, I mean, you're not exactly wrong, but the plasma comes up in loads of places. The stuff that streams off the sun is called the solar wind. And it happens every day, every minute of every day, very frequently. The magnetic South Pole, well, the south end of Earth's magnet is at the geographic North Pole. Well done if you managed to work that out. I've made that incredibly confusing. A particle that streams off the sun is an electron. It is electrons and protons that stream off the sun. And the name of the teardrop-shaped magnetic barrier that protects us from the solar wind is the magnetosphere. So we're close to a bingo. So we've got solar wind every day, electron, magnetosphere, and North Pole. What was the next question? I can't remember. Oh yeah, atoms in our atmosphere that collide with the solar wind, they are excited. It is very exciting. And question 7, the front of the magnetosphere where the solar wind collides with Earth's magnetic field is the bow shock. So well done. This is where you should have had your bingo all along the bottom of the third, all along the third line. And I don't think I bothered to answer question 8, but if you did that one, then a compass needle is magnetic would have been the right answer there, but it wouldn't have helped you to get a bingo. All right, you lot. Right, come up here with me.
So that is the end of our lesson about the Northern Lights. Oh, just before you go then, very quickly, why do we usually call them the Northern Lights? Because this happens at the South Pole as well. There are Southern Lights and Northern Lights. They happen just as much. They don't happen at exactly the same time, but other than that, they're pretty much exactly the same. The proper name for them is the aurora. That's the proper word. But we usually talk about the Northern Lights. We don't usually talk about the Southern Lights. Why is that?
I'm just flashing you my globe as a clue. So here's the North Pole, the Arctic Circle around it. Here's the South Pole with the Antarctic Circle around it. Why do people normally talk about the Northern Lights? Why do we not talk about the Southern Lights? Sort of helps, I guess, if you've been to previous lessons. For once, it's not just British people thinking that it's all about them and calling it the name of the ones that are near them. It's just that, did you get it? More people live near the North Pole, don't they? So the North Pole is in the middle of the sea, but we've looked at how it's surrounded by all kinds of different countries, loads of different people living around the North Pole that can see the Northern Lights, whereas the Southern Lights happen above the South Pole, which is Antarctica. Very, very cold and inhospitable. There's a few people there, but this is why we normally talk about the Northern Lights, because those are the ones that most humans get to see. Right. Thank you very much for coming. If you are on Facebook, then every time I'm live on YouTube, because there's no comments on YouTube, I always put a post on my Facebook page saying if you want to comment and say hello, then I will look at my Facebook page at the end of the lesson and say hello back to you. So I'm going over to my Facebook page now. So if you haven't been over there to say hello, feel free to go over there now. If you're watching live, if you're watching on catch up, I mean, you can still go over, but the post won't be at the top. It'll be somewhere deep, deep down on my page. If you have enjoyed these lessons, and you want to support me, if you usually pay your teachers for the information that they give you and you're thinking, this is just as good as the ones that I pay for, you can pay me. Somebody has to. This is how it works. It's such a cool business model that I just accidentally fell upon because of lockdown. Everything that I do is free. So I stream these all ages lessons. Next term, we've got a week off now for half term, and next term I'm doing 5 weeks of Shakespeare lessons, which I've never done before. I've always stuck to science, but we're going to do a little bit of theatre just for 5 weeks. So they're all free. The printouts that you can get from my website and my Facebook group, they're free. I do IGCSE physics lessons in the same way, they're free, and I do a Lego Storytime show every week. Like I say, the next one, which if you're watching live, is on at 10:30 on my YouTube channel, and that's about the Northern Lights. Yeah, it's all free, but people who choose to can support me with £5 a month, and that is enough just to keep me going. So it's on this website called Ko-fi. If you go to my About section on YouTube, it takes you to this website called Ko-fi. Or you could just, if you search Ko-fi Theatre of Science, then it's the first thing that comes up. Oh yeah. So if you send me £5 a month, that is enough for this to be my job, because there's loads of you. But hopefully it's not too much from you for what I'm offering. It's just working out really well for everyone. Like, everyone's super grateful. I'm really grateful to you, and you're really grateful to me. And I feel like sometime soon someone's going to work out who should be grateful, and it'll all crumble. But at the moment, it's working brilliantly. I even write a science magazine, which I send out to my supporters to say thank you. Now, at this point, if you are supporting me, you might be rolling your eyes, because the next magazine is really overdue. It just comes out whenever I finish it. But the next magazine, which is on acids, is really overdue by my already shoddy standards. But if you sign up to support me, you'll be on the list to get that magazine. And I will send you a past magazine to tide you over. So the past magazine that I'm sending out at the moment is on sleep. Husband is a graphic designer. Super useful. So if you sign up, you get this sleep magazine, which has an origami koala bookmark in it that you can make, because koalas sleep the most. It's got an article about what actually happens in your brain when you are sleeping. It's got a comic about maybe we used to not sleep all the way through the night, and that was fine. It's got a choose your own adventure, where depending on how much you know about sleep, things will end very well for you or very badly. I really like that one. Oh yeah, and I send you a little sachet of organic lavender and some material so that you can sew your own sleep swish, which is scientifically proven to help you sleep. Sleep squish, like a little squishy. Oh yeah, and there's a jigsaw at the back as well. I'm very proud of Theatre of Science magazine. And I'll send you some rainbow glasses that makes you rainbows. They're amazing. Oh, they're so great. And a description, a little information thing I wrote about how they work. So all that will come in your welcome pack if you sign up to support me now by searching Ko-fi Theatre of Science. If you sign up with £6 a month, I know, I never talk about that, I'll send you an extra bonus magazine in your welcome pack. This one is on rainforests, and it also has a choose your own adventure, and talks about some rainforests that are in Britain. And yes, right, so thank you, loyal, regular followers who've had to put up with that advert. You're like, Lara, I've been supporting you for 3 years. Can you just read out my name? Wow, so many comments. Amazing. That's good. Usually if there's loads of comments, it's people saying things like, you're writing backwards, because then you don't have to, because you're on YouTube, not Facebook. Hello, Violet. Oh, there's Bethany and Bonnie. Oh, no, you're not feeling very well. So you're watching from the sofa under blankets. Oh, Bethany and Bonnie, I hope you feel better soon. It could be worse. You could have 2 broken legs because of a bunk bed related incident. We will get to that comment in a bit. Oh, Gus has made it to a live lesson. No, for the first time, Gus. I can't believe you had to sit through this long for me to say, hi, Gus. Oh, brilliant. Made it to a live lesson for the first time. That's very cool. That's exciting. Hello, Kenton. Oh, hello. You're so welcome. Dude, no, thank you for ordering the rainbow glasses in the magazine. Very much appreciated. You definitely saw the purple candle. Yeah, me too. I don't know why anyone watches these lessons on Facebook. I really don't. Facebook's just like a dress rehearsal for the YouTube lesson, which is always better and more successful. Oh, this is very good. Oh, Bella's here. Amber's here. We made candles last week, so we might use the homemade candles to do the activity that is so homemade, isn't it? That's like the most homemade thing I've ever read. Today, we did an experiment to learn about the Northern Lights using candles that we made last week. Oh, homemaders. It's so smug. Hello, Edmund. Watching live. Yes. We're trying to do the floating needle thing with the leaf, but our needle sinks. Oh no. You had to rest the needle on a polystyrene disc. And that is resourceful. Oh yeah, and that's excellent. You got the correct bingo. That's good. No, John and Seamus, it's snowing. They are tuning in, but also impatient and excited to get outside. Yeah, I'm not surprised. I've just got drizzle here. I did read that it was going to snow today. Snow is, Seamus is telling me the snow is falling from stratus clouds. That's everyone's favourite lesson that we've ever done. We did a weather module, and one of the lessons in the weather module was about clouds. And we looked at, we named like 5 different types. We didn't name them, they have names, but we talked about the 5 different types of clouds and said each name in a different way. And the stratus clouds are just really boring. Yeah, I've got stratus clouds here. If it just looks like the sky is white, that's the really boring stratus clouds. So you've got to go, stratus. Stratus. Seamus is just full of the stratus vibes today. Well, probably not, because it's snowing, so that's exciting. Harry from Georgia, we watched yesterday, but had to see me dressed up today. I'm so sorry. I'm like, if I've gone to war with the Northern Lights, that's what this is. If I'm like stalking the Northern Lights, I don't know. I need to wash this off before Lego Story Show. Candles burn great, yes. Oh, good. Oh, and Georgia, you liked bingo. Amber's mum here. I totally read small leaf, needle or pin in the preparation instructions. Amber's mum thought it said, what did it say? Small leaf. I think it said bit of leaf. So Amber's mum thought it said small leaf. Oh, small leaf, needle or pin, and went out to get a pine tree needle. I get it. No, that makes sense. Small leaf, needle or pin. So you went out to get a leaf that looks like a pin. That's adorable. That's really cute. I can't believe that's so specific. Guys, I'm really proud of the fact that I only ask you to get household objects. I would never specify what shape of leaf you need. Hey, Amber's mum, quick, there's only 30 seconds. It's starting. Can you just go and find a leaf that looks like a pin? Yeah, Bella's mum is having a hard relate to that kind of thing. Oh, no! Bella has sent a picture of the Northern Lights that your friend's dad took when he was at work with the Royal Navy. Whoa! Bella, your friend's dad is so much better than your dad. That is cool, isn't it now? Come on. Friend's dad took when he was at work with the Royal Navy. P.S. My dad is out on a bike ride on his new bike. Bella's dad's. Everyone, I don't usually, I usually like everyone, but Bella's dad is the enemy of the Science Alliance. But look how cool Bella's friend's dad is. No way. Just took that photo whilst at work with the Royal Navy. Bella's dad's always got some absolutely pathetic excuse for not coming to the lessons, like, oh, saving some humans' lives. Oh, I was planting a tree. Just get with the program, Bella's dad. Fabulous outfit. Scream Northern Lights. Yeah, thanks, Ray. Clear! You are here, and I will see you soon. Very soon, actually. I've only got 40 minutes, haven't I? I've got to reset Lego Story Show. Look at Lego Story Show at the moment. It's just a complete mess. Look at this. This is not a scene. This is just lots of different bits of scenes all stuck together. I very much need to go and sort that out before past. Hello, Michaela and Tegan. All right. Oh, Pat, I know. It's not the last lesson. It's just the last Polar Regions lesson, but I know we could have done more. Lana and Margot. Hi, Margot. I didn't know you were there. And it's snowing heavily-ish. Snowing heavily-ish. That's like my child being 6 8/7. Grace and Hope are watching with 3 polar bears, an Arctic fox, a reindeer, a seal, and 2 snowy owls. Yes, this is a grand finale. That's very cool. Wish I'd brought all my toy narwhals now, assuming that they're toys. If I hope they're toys, because that is not a good combination food chain wise. You don't want to mix polar bears with Arctic foxes, reindeers, seals, and snowy owls. You have some pine cones, Bella, for your log burner, that when you put them in, they make the flames blue and green. Oh, well, that's cool. It's not as fun as doing all this faff with coffee filters, but that is very cool. Oh, and I mean, you've listed the ingredients. What is the ingredient in these magic pine cones? Oh, yeah, copper sulfate. Look at that. And ammonium chloride. Ammonium chloride. My nose is really running. Oh, no, it's too much. I can't. I thought I could brazen it out to the end of the comments, but I can't. There's too many comments and my nose is too gross. Oh, you love the bingo. All right, I will do that again. Scrolling down. Past the Grace and Hope wrestling polar bears. Oh, hello, Arthur and Abba. Hello, Arthur and Abba. There's Clear again. Oh, there's Edward and Annabelle and Evelyn and Rose. Hello. That's nice. You're really upping my numbers. Annabelle and Edward and Rose and Evelyn. Hello. Hi, I'm watching live. Oh, hello. Hello. I see. Oh, that's good. All right, Ethan. Hello, Robin and Hissy. Went to the Science Museum in London on Monday. I'm going to the Science Museum in London at half term. I'm very excited. I think I'm going to try and go to the IMAX. Edwin and Solomon and Jeremiah, hello. Happy, are you having a science day? Maybe not. Anyway, I'm very pleased that you have enjoyed learning about the colours. All right, Emmy, I watch a lot of lessons, but I don't usually remember to say hi. Hi, Emmy, you've just been lurking this whole time. That's very cool to read your name. Hello, thank you for coming all the time. Thank you for letting me know that you exist. That's ace. There's something called the Aurora Curl where it goes all wiggly. Oh, is there? Oh. Whoa, Aurora Curls, what are they and why do they happen? Okay, open link in new tab. I've got 38 minutes to learn about those and then tell you about them in the Lego Story Show. Thanks very much. Oh yeah, they're very curly. All right, Kaya and Surin in Yorkshire. That is also where I am. All right, Sky and Evie. Hello, Sebastian and Humphrey. It was... Oh, twist! Sebastian and Humphrey, it was Mummy who broke both her legs. Your legs are fine! How on earth do Sebastian and Humphrey have bunk beds and it's their mum who broke both her legs in a bunk bed related... Is that the same mummy who got attacked by the goose? Sebastian and Humphrey's... you should never share personal information over the internet, but I really want to know what on earth were you doing? You broke your right ankle and your left foot. I mean, it's bad when it's kids. Kids, don't get me wrong, it's bad when you break your bones, but kids are so, robust and, kids' bones heal really easily. Mummy's bones, no, mummy's bones are weak and brittle and should be cared for. Dude. It's just making all my bones, feel all, just thinking about it. That would be a good piece of creative writing for you if you want to have a different lesson today. How does a grown woman break both legs with a bunk bed? A bunk bed. It's just a solid wooden... Were you on the bunk? Why were you on the bunk? Suki, Arza, Eunice, Musa, Sulla. Greetings. Luna, hello. Violet, greetings. Oh, Violet. Oh, Violet's a potentially other adult watching. Hello, where is the YouTube link? Look at that, Bella. Thank you. You put it on. That's good. Imogen Ophelia, hello. Hiya, Ava. We will be watching from hospital. Right, okay. Oh, now there's 12 replies. Okay, good. So maybe we've got more details about how on earth... Bunk bed's not a goose attack. They came out of nowhere. They came out of nowhere. We thought the bunk beds came out of nowhere. Oh, good. Look, Robin is saying that it hopes. Oh, so Robin, you know Hissy and Robin. That's nice. The kids are excited that I'll go beep in the airport because you've got your ankle full of metal. That's really awful. Oh yeah, there's a lot of comments saying that we're really thinking of you and you're watching a lesson while you're in hospital. So dedicated to a lesson on x-rays. That is awful. Okay, I can't imagine that Sophie is still here. But Sophie, if you are still here, this is your first lesson and I've definitely chatted more than I've ever chatted before, and that is saying something. But welcome to the Science Line. So good to see you. We're gathering objects. Quite curious to see what they're for. Yeah, it was quite random. Oh, we were still watching and she heard her shout out. Yeah, amazing. And now you're recharging your needle. Excellent. Oh, that's good. Okay, right. I'm going to go. Yes, I'm going to go. I've reached the... I'm just going to refresh the comments because it's really annoying for people when I go to the comments and then I chat and then they're like, oh, hi, we didn't realise we could comment. And the live stream has ended. Oh, there you go. See, here's Max. This is the first time I've actually commented, I liked your penguin lesson. Oh, thanks, Max. I'm assuming that that's not like, that you're saying, I liked your penguin lesson. Not, I liked your penguin lesson. This lesson, what have you done with your face? Amber, magnetosphere looks like a spider. She's like, tell Lara, does it? Max, hello, I'm very excited that you have commented for the first time. That's amazing. What is it about this lesson that has brought some people who've been watching for ages out into the comment section? What did I do? I must do it again. Magnetosphere looks like a spider. Does it? Magnetosphere looks like a spider? This needs fact checking. Let's have a look. Oh yeah, it really does. It does. It does look exactly like a spider. Yeah! With the head and the body and on all the legs. Man, that is totally uncanny, isn't it? Yeah, thank you for that. You're quite right. Hadn't spotted that. Oh yeah, and there's Jay and Daisy and Daniel. You see, it is worth me refreshing the comments. Excellent. Right. Whew. So I'm going to go. Because... yes, good. And that is everybody's comment. Right, I'm going to go and set up Lego story time. I will see some of you in like 33 minutes, but obviously you can watch on catch up. If you've had enough screen time today, you want to run out and play in the snow, then I will see you whenever I see you. So next week, there's nothing because I'm on half term parenting my children, but the week after that, the all ages lessons are on Shakespeare, the IGCSE physics continues with magnets as usual, and the first Lego story show back is on the Globe Theatre because of the Shakespeare. Right, yes, I will see you all very soon. Thank you so much for support, you lot. Hugely appreciated. Bye.